Hello everyone, Bill Nye here. Today we're diving into the world of computer science, specifically debugging. Imagine building a model rocket. You press launch, but nothing happens. That's a bug, an error stopping things from working. In software, a bug is any mistake in code that causes unexpected problems. The term bug comes from 1947, when engineers found a real moth causing a computer malfunction. They taped it in their logbook as the first literal bug. Debugging is the process of finding and fixing these errors. Think of it as detective work. You gather clues, test ideas, and hunt down the faulty line of code. It's not about blame, everyone makes mistakes. Debugging is about solving puzzles. Your goal? Make your program run smoothly just as you designed. Like a doctor diagnosing a patient, you examine symptoms, run tests, and prescribe a fix. Debugging is the essential process of diagnosing and treating your software's problems. Every programmer, beginner or pro, spends time debugging. It's a key part of creating anything with code. Why is debugging so important? Because almost everything runs on software. Phones, traffic lights, even microwaves. Bugs can be annoying like a crashing app or dangerous like errors in airplane or medical software. Debugging makes technology reliable and safe. It's also the best way to learn. Fixing bugs teaches you how code really works. Good debugging skills save time and reduce frustration. Debugging is scientific. Observe, hypothesize, experiment, and fix. Mastering this process helps you solve problems everywhere, not just in code. Debugging turns challenges into opportunities to learn and improve. Let's put on our detective hats. First, reproduce the bug. Find the exact steps that caused the problem. Write down what you did. Open the program, click a button, see the crash. Once you can trigger the bug, gather evidence. Use print statements or logs to trace what's happening. Narrow down where the problem is. User interface, logic, or data. Analyze the suspect code line by line. What did you expect? What's actually happening? Form a hypothesis. Maybe the program crashes because it tries to divide by 0. Test your idea by changing the code. Add a check for 0 before dividing. Run the steps again. Did the bug disappear? Don't stop there. Test other parts to make sure your fix didn't break anything else. This is called regression testing. Debugging is a cycle: reproduce, isolate, hypothesize, fix, and test. Each step brings you closer to a working program. That's the detective work of debugging. Let's look at common bugs new programmers face. The off by 1 error computers count from 0, so a list of 10 items goes from 0 to 9. Accessing item 10, crash. Typos are another classic. Misspelling a variable or missing a semicolon can break your code. For example, using username and username as if they're the same, they're not. Type errors happen when you treat text as numbers. Adding 5 inches and 10 inches as strings gives you 510, not 15. Always check your variable types. Uninitialized variables are sneaky. Forget to set a starting value, and you get unpredictable results. Always give variables a sensible starting value. Careful proofreading and understanding how your code works are your best defenses. Spotting these bugs early saves hours of frustration. To master debugging, develop professional habits. Don't panic. Take a break if you're stuck. Sometimes explaining your code out loud, even to a rubber duck, helps you spot mistakes. Use the right tools. Debuggers let you pause code, inspect variables, and step through line by line. Learn to read error messages. They often tell you exactly where and what went wrong. If you're stuck, search online. Chances are, someone else has had the same problem. Debugging isn't punishment, it's a vital skill. Be systematic, reproduce, isolate, hypothesize, fix. Learn from every bug, each one is a lesson. Use all the tools at your disposal, from print statements to debuggers. Be patient and persistent. Every programmer spends time debugging. Turning broken code into working software is what makes programming rewarding.